Good morning, everyone. Today, I will be presenting my portfolio project on predicting diabetes. First, I will introduce what diabetes is, followed by a brief explanation of the dataset I used. Afterwards, I will go over the features I created, the models I used, and the final model that produced the highest score. Lastly, I will finish off the presentation with improvements I can make to improve the model. So what is diabetes? Diabetes is a chronic disease that reduces an individual's ability to effectively regulate glucose levels in the blood due to a lack of insulin. Complications include heart disease, vision loss, kidney disease, and so forth. Although these complications can be mitigated with proper care, diabetes is one of the leading causes of death in the world. I got the diabetes health indicators dataset from Kaggle. The dataset was obtained from the Behavioral Factor Surveillance System, which is a yearly telephone survey that collects data on Americans' health-related risk behaviors. The original dataset had approximately 440,000 responses with 330 features, and this dataset extracted about 250,000 responses and kept only the features that are relevant to diabetes, bringing it down to 21 features. It is also important to note that this data set is unbalanced, meaning that there are more non-diabetic participants than diabetic. I felt a little guilty choosing this data set because the data set values were also cleaned. Most columns are categorical except for BMI, physical health, and mental health, which asks how many days of poor mental or physical health in the past 30 days. One thing that I found strange was that all of the BMI values ended with point zeros, meaning that they most likely rounded these values. So for feature engineering, all these features are relevant, but the ones I decided to focus on are diet, activeness, smoking, and healthy drinking. A healthy and balanced diet is recommended to prevent diabetes, so I created a feature to indicate whether they incorporate fruits and vegetables into their diets. Being physically active less than 3 times a week increases risk of diabetes, so I create a feature for whether or not the participants fulfill that requirement or not. From that, I also create a feature to determine if they are both active and eating healthy. Smokers are 30 to 40% more likely to develop diabetes, and excessive drinking also contributes to diabetes, so I create a feature to identify if a participant is both a smoker and a heavy drinker. Afterwards, I ran a few baseline models of these features and removed whatever scored low. And one of them, unfortunately, was smoking and heavy drinking. For models, I chose all the relevant classification models, which are decision tree, random forest, SVM, and logistic regression. I left out KNN because lesson learned from previous projects, it takes too long to run and does not yield good results. I also use SMOTE like Roslyn, which is an oversampling technique that works like KNN. It selects examples that are close in the feature space. It draws a line between the examples in that space and then draws a new sample at a point along that line. The authors of SMOTE also suggested using random undersampling in conjunction to SMOTE, so I included that as well. And here are the results from the models after tuning. This was evaluated by looking at the precision, recall, and F1 score that the model predicted as correct. Accuracy will not be a good indicator for this since the result is imbalanced. For decision tree parameters, I use Gini and entropy for the criterion and also have max depth and min sample split. For random forest parameters, I use n estimators and min sample split. And as for SVM and LR, I was running out of time, so I simply just used the basic model for those ones. For deep learning, I created a simple sequential model in Keras and played around with the hidden layers. Here I use softmax as the final activation layer, as well as sparse categorical cross entropy for the loss function. I found that this gave me a better result than sigmoid as the final layer and binary cross entropy for the loss function. This simple deep learning model has a higher accuracy than my previous models. However, I was having troubles getting precision recall and F1 score, so I cannot accurately compare this to the other models. In conclusion, the best model is random forest with SMOTE and hyperparameter tuning. The top 3 most important features are BMI, age, and also general health. Weight gain is a common risk factor for diabetes. So BMI is a good indicator for this because weight gain may increase insulin resistance. People who are over 45 years old are more at risk for getting diabetes because they get insulin resistant as they age, and their pancreas, which makes insulin, deteriorates as they age as well. General health is a personal evaluation of the participant's own health, and this is a good summary for the rest of the features as long as they're being honest. And although this model is not good enough to be used in a real setting, knowing how these risk factors are weighted is valuable information nonetheless. For type 2 diabetes, early detection is important for preventing diabetes. For example, if someone who is about 50 years old and is rapidly gaining weight, if they know that they are in the risk group for diabetes, they may be concerned and start losing the weight that they gained. These risk factors can also be used to advance healthcare technology because they can be used as new leads and also help with healthcare treatments. They can also be used to predict supply and demand for insulin. And insurance companies also need risk factors to assess premiums for their customers. Since companies are not allowed to use ethnic background as a feature and reasoning behind assessing their premiums, this data set would be suitable because it doesn't have that feature. To improve my model, my next steps would be to examine other people's code and learn from those. One of the entries I saw used was SMOTE and ENN, which got them an F1 score of 96 with good precision and recall. I would also like to learn more about deep learning since a basic neural network yielded a higher accuracy than my other models. Further tuning will likely yield better results. Lastly, I would like to use my model on a bigger dataset and perhaps even the original BRFSS dataset. And thank you for listening.